Hello dear students, so now we would move on in this chapter number 2 of class 6th mathematics. So here are some questions for you. First question is find prime factorization of 1729. Arrange the factors in ascending order and find the relation between two consecutive prime factors. So this you have to do. Okay. So first we have to find out the prime factors of 1729. So how would you find this? Find prime factors of 1729. So I would divide this all by the prime number. So first I think it is divisible by 7. How many times? 7 2 are 14, 3 left. Then 32, 7, 8, 4 are 28. How much left there? 4 left. Then 7 7 are 49. So answer would be 247. Now 247 is divisible by which prime number? It is divisible by 13. How many times? If you see 13 1 ja 13. How much is the remainder? 11 is the remainder. Okay, and it would become 117 then. So 13 9 ja 117. 19 is again the prime number, would be divisible by 19 only. So answer would be 1 then. Okay, so this is how we have the prime factors. Now we have to arrange the prime factors in ascending order. Okay, so you would write this as 1729 would be equals to 7 multiply 13 multiply 19. So this is how we have arranged them in ascending order. Now one more thing you have to find out. Find the relation between two consecutive prime vectors. So what is the relation between two consecutive prime vectors? If you see, what is the difference of 13 and 7? It is 6. And the difference of 19 and 6? Again it is 6. So you would write the difference between each prime factor is 6. Okay? Or you can say the later is 6 more than the previous one. Okay? Here in two consecutive terms, the later is 6 more than the previous one. Means later one is 6 more than the previous one. In each, here also 6 more, here also 6 more. Are you getting this? Yes. So this is how you would solve the given question. Okay, just note it down. So this is the second question. Question is which factors are not included in the prime factorization of the composite number? Which factors are not included while you are factorizing the composite number? Let's say we have a composite number 9. Okay, so if you factorize, if you just find out the prime factors of 9, so it would be 3 3 ja 9 and 3 1 ja 3. So you are getting the prime factors as 3 multiply 3. Next composite number, suppose we have another composite number that is 4. If you divide this 4 by the prime number, let it so it is divisible by 2, so it would be divisible 2 times. 2 2 ja 4, again 1. So prime factors of 4 are 2 multiply 2. Okay, similarly one more composite number, let's take 10. If you find out the prime factors of 10, first divide it by 2. 2 5 ja 10 and 5 1 ja 5. So prime factors of 10 are 2 multiply 5. Okay, so this is how we have many examples of the composite number. Now if you see the prime factors of the composite number, so what factors are not included here? It means the given number is not here, and 1 is also not there. Are you getting this? So in the prime factors of the composite number, any composite number you take, okay, so in the factors of the composite number, you would not find the number itself and the 1 as the prime factor, because 1 is not the prime factor, so you cannot write 1. And the given number is also not the prime number. 9 is also not the prime number, so you cannot write 9 there. Are you getting? So in the prime factorization of the composite number, which numbers are not included? Means the number itself and 1. These two numbers are not included in the prime factorization of the composite number. So which numbers are not included? Not included in the prime factorization of the composite number means the number itself and 1 are not included in the prime factorization of the composite number. So you would write here, hence in the prime factorization of composite numbers, the number itself and 1 are not included. Okay, But suppose we are factorizing a prime number. Let's say we have a prime number 5. So what would be the prime factors of 5? 5 is divisible by 5 only. So you would write here 5. Are you getting this? So the prime factors of the prime factorization of the prime factor would be including the number itself. But if you are factorizing the composite number, so their prime factor would not be including the number itself and the 1 there. Are you getting this? So just write it down. So here in this question we have two factor trees for the 60. Here are two factor trees for 60. Write the missing number. The missing number you have to write here. Okay. We have two factor trees for the 60. This is the first one. This is the second one. So here you have to find out the missing number there. Okay. So now if you see the factors of 60 here, like here 6 10 just 60. Yes. And now the factors of 60 are what? 2 and what? 2 3 just 6. So factors of 6 would be 2 multiply 3. So the missing number would be 3 here. Similarly here, what are the factors of 10? 5 2 ja 10. So what would come here? Here would be the digit 2. Okay, this is how you would write the missing number. Similarly here also, if you see the factors of 60, 30 multiply which number? 32 ja 60. So what would come here? 2. Similarly factors of 30, 10 multiply how much? 10 3 ja 30. Okay. Now again factors of 10, 2 5 ja 10. We have to write the prime factors there. 2 5 ja 10. Are you getting it? This is how you would write the missing numbers. Just note it down. Here in this question you have to test the divisibility by 2. Test the divisibility of the following by 2. Means you have to check without dividing. You have to check whether the given numbers are divisible by 2 or not. Divisible by 2 means if you are dividing then by 2, then the remainder should be how much there? 0. There should not be any remainder. Okay. If this is so, then such numbers would be divisible by 2. Okay. So but without dividing you have to show that which numbers are divisible by 2. So how do you prove this? How do you show? If you want to show the given numbers whether it is divisible by 2 or not, so how would you show this? Do you have any idea? Yes. Write in a box there. This you write in a box here. Okay. Here you write the numbers ending with 0 2 4 6 8 are divisible by 2. Means any number which is ending with 0, either 0, 2, 4, 6 or 8, such numbers would be divisible by 2. Okay. If the number is ending with any of these digits, then such numbers would be divisible by 2. So if you see in the first case, the number ending with the digit 0. So here we have the example here. Okay. So if the number is ending with 0, so it would be divisible by 2. Yes. So this is divisible by 2. So you would write here in the first case 6250, it is divisible by 2 since it ends with 0. Any number ending with 0 would be divisible by 2. Okay. Similarly, what would be the answer of the second question? Look here. This number is ending with 5, but we have not such case here. Okay. So the last digit should be 0, 2, 4, 6 or 8. Yes or not? But here it is 5. So this number again would not be divisible by 5. So you would write here 984325 is not divisible by 2 because it ends with 5. Okay. Are you getting this? Not divisible by 2. Here it is by. I'm just writing it up. Okay. Then what would be the answer of this third question? Whether it is divisible or not, just tell me. If you see, this is again ending with the digit 4. Ending with the digit 4. Any number which is ending with 4 again would be divisible by 2. So you would write here as 3671314 is divisible by 2. Why? Because it ends with 4. Okay. So this is how you would test the divisibility by 2. Similarly, you have to test the divisibility of the given number by 3 also. So how to test the divisibility by 3? Just write it down. I am going to erase this. Let's say you have to test the divisibility by 3. Just I am changing the question. Test the divisibility by 3. Okay. So what, do you have any idea which numbers would be divisible by 2? Sorry, divisible by 3. Now if you see, if the sum of the digits of a number, remember, if the sum of the digits of a number is divisible by 3, then the given number would be divisible by 3. So write it here in a box. If the sum of the digits, all digits means, okay, if the sum of the digits in a given number, is divisible by 3, then the given number is also divisible by 3. Okay, the sum of the number should be, the sum of the digits of the given number should be divisible by 3. This is the condition here. Okay, let me write some example. Let's suppose we have the number 70,335. This is the first. Then you have the second question here. Let's say it is 607439. Then we have the third question here, that is, let's say it is 9, visible there, yes, 9082. Let's say it is 746. These are the given numbers. Now you have to check their divisibility by 2. So if you see the first one, answer of the first one. So first what we have to do, we have to add the digits of the given number. The sum of the digits of the given number should be divisible by 2. So first we will find out the sum of the digits. Sum of the digits. So it is, first number is 7 plus 0 plus 3 plus 3 plus 5. If you are adding these all, how much you are getting? Just add 7 plus 0, 7 plus 3, 10 plus 3, 13, 13 plus 5, 18. Now if you see 18 is divisible by 3 or not? Yes, 3 6 is 18. Yes, 18 is divisible by 2. So if the sum of the digit is divisible by 3, then the given number is also divisible by 3. So you would write there, hence 70335 is divisible by 3. Why? Because the sum of the digits is divisible by 3. Okay. Similarly, you would do the second question also. Second question is 60. It is 7439. So again you add all the digits there. Sum of the digits. So it is 6 plus 0 plus 7 plus 4 plus 3 plus 9. Add all the digits. So how much you are getting? Just if you are adding 6 plus 0, 6 plus 7, 13 plus 4, 17 plus 3, 20 plus 9 would be 29. Now I think 29 is not divisible by 3. 3 9s are 27, 3 10s are 30. So 29 is not divisible by 3. So you would write the given number is not divisible by 3. Right here. Hence the given number is not divisible by 3. This is how you would write the answer of the given question. Similarly, you would do the third question also. Okay. So how would you solve this third question? Again, add the digits of the given number. If the sum of the digits is divisible by 3, then you would write yes, the given number is divisible by 3. Okay. So this is how you would solve the given question. Okay, that is all for today. We'll be discussing some new question later in the lectures ahead. Till then, stay tuned and keep watching. Thank you. Have a good day.